Welcome to the second of 3 videos. I've changed over to a separate sheet of paper just so I could have a little bit more room. I am going to pick the left side of this equation to solve just because it's more complicated. Tying back to those basic skills that we talked about at the beginning of the unit, if I want to add these two fractions together, I need a common denominator. And my common denominator is the product of all the unique denominators in this problem. So my common denominator is 1 minus cosine theta times sine theta. My first fraction had a 1 minus cosine theta, and to form the new one I had to multiply by sine. So I've got to multiply the numerator by sine as well, and I end up with sine squared theta. My second fraction had a sine theta. It needs a 1 minus cosine theta, and whatever I do to the bottom I've got to do to the top as well. So this is 1 minus cosine theta times 1 minus cosine theta. I'm going to multiply these two things together. And I'm going to use a little bit of algebraic trickery here. I notice this sine squared and this cosine squared in the same line. And if I refer to my pink card, I also see that sine squared plus cosine squared is equal to 1. So I'm going to combine these two together, and they form a 1. So now I have 1 plus 1 minus 2 cosine theta over 1 minus cosine theta times sine theta. I can combine like terms. And then I can factor out a 2 in the numerator. And then we can use our lightsaber. We end up with 2 over the sine of theta. That's a reciprocal function, and it becomes 2 cosecant theta, which is what it was supposed to be. Moving on to example B. My second example, we're trying to prove that 2 secant squared x equals 1 over 1 minus sine of x plus 1 over 1 plus sine of x. Again, I've got two fractions that I'm trying to add together. I'm going to pick the right side to work with this time because it's slightly more complicated. I identify my common denominator, which in this case is 1 minus sine x times 1 plus sine x. And I multiply the numerators by the missing piece of the denominator. My original denominator was 1 minus sine x. My new denominator is 1 minus sine x times 1 plus sine x. So I'm going to multiply my first fraction by 1 plus sine x. For that same reason, I'm going to multiply my second fraction by 1 minus sine x. At this point, we start using some algebraic manipulation. I have 1 and 1. They make 2. And then my sine x minus my sine x, lightsaber time, cancel those out. And then on the bottom, these two things follow the pattern of the difference of squares, and so when I multiply those, I get 1 minus sine squared x. Again, going back to the pink card, I notice that 1 and that squared term. Here's that 1 and that squared term. So 1 minus sine squared x is cosine squared x. And if I have a cosine squared x on the bottom, that's the same thing as having secant squared x in the numerator. Let's move on